Alright, so now that we're done with Unit 1, we're going to start talking about some different topics. We're going to start talking about properties of equality. We're going to talk about graphing systems of equations and systems of equations in general, finding solutions for two equations at a time. So it's going to always be the point, the x and y values, that would satisfy both equations at the exact same time. So what we're going to start with is graphing systems of equations and what systems of equations are. So this worksheet right here that is totally empty in front of you, this worksheet is the attachment to the video. And what you'll need to do is, if you haven't done it already, you need to go to the attachment and print it out. So pause the video, go print out this worksheet so that you can fill it in, or you can just copy everything down and just take notes that way. Either way is fine. So we're going to talk about graphing systems of equations. So first of all, systems of two linear equations. So what that is it's two equations with two variables each, and it's an x and a y. So this is the general form. So I've got ax plus by equals c, and dx plus ey equals f. Oh my gosh, that's so many letters. Don't worry about it. This is just an example. Your a, b, and c would be filled in with different numbers every time. So if I had 2x plus 3y equals 4, this would be 5x plus 6y equals 7. So it's just saying that these the numbers in front of x would have to be different, the numbers in front of y are probably going to be different, and the numbers at the end that it's equal to might be different as well. So the solutions to a system of equations, when you've got two equations like this, you have exactly one solution, and that's one ordered pair. Alright, so an ordered pair is an x and a y, and it makes both equations true. So whatever this x and y is, it's the same in both equations, and it makes them both true at the same time. So let's check to see if an ordered pair are solutions of a system. So this is an example of a system of equations. This x has a coefficient of 1, this x has a coefficient of -2. This y has a coefficient of -3. This y has a coefficient of +3. The numbers on the end are -5 and 10. They're just different numbers. So for the first one that I'm going to do is I'm going to check to see if the point 1, 4 is a system, or is a solution to the system of equations. So what I need to do is I need to plug in 1 for x and 4 for y. So I go through the very first equation and plug in 1 for x and 4 for y, because that's an xy. When I plug those in, I would get 1 minus, and then 3 times 4 is 12. Does 1 minus 12 equal -5? So is 11 equal -5? No, it doesn't. So that sign right there means does not equal. So -11 does not equal -5. So no, this one doesn't even satisfy the very first equation. So this wouldn't be a solution to the system of equations. So let's try the point -5, 0. So I'm going to plug in -5 and 0 and see if it equals -5. So -5 plus, and then 0 times -3 is 0. -5 plus 0 is -5. So the first one checks out. That works. So now I need to plug in -5 to the second equation. So -2 times -5 plus 3 times 0. Well, the 3 and 0, that just pretty much goes away because it equals 0. -2 plus -5 equals 10, and 10 does in fact equal 10, so it works out as well. So this one point makes the first one true, and it makes the second one true. Therefore, it is a solution to the system of equations. So there's different ways that you can find out what that point is. So this is, we just guessed at a point and to see if it works. Okay, but there's an easier way than guess and check, because there are literally an infinite number of points out there. You wouldn't be able to test them all. So there's several different ways that we can figure out how to solve a system of equations. One way is graphing. Another way is something called elimination, and another one is called substitution. In Unit 2, we're going to be learning about all three of those things, and we're going to start with graphing. So what we're going to do to solve a system by graphing is you graph each equation, that's supposed to be equation, on the same coordinate plane. So on the same XY chart, you're going to graph two lines. Okay, if the lines intersect, the point, or that ordered pair, the XY, is where the lines intersect, is the solution. So if I graphed y equals 3x minus 12, so that would be this line right here, starting at -12 would be way down here. and y equals negative 2x plus 3. So you start at 3, over 2, down 2, and graph the two lines on the same xy coordinate plane. The point where they cross at positive 3, negative 3, that is the solution to that system of equations. If we look over here, I graphed y equals negative x minus 2. So I start down here at negative 2, and I go up 1 to the left, and I graph that line. Then I get y equals 2/3 x plus 3, so I start here at 3, and I go up 2 and over 3, and down 2 and over 3. That point right there where they cross at negative 3, 1, that is the solution to the system of equations. So it's simply graphing two lines and seeing where they cross. So here are two more examples. When we graph the two lines, they cross at the point negative 1, 3. That's the solution. And then this example here, you graph the two lines, and they both, you got to keep in mind, you've got to get it in y equals mx plus b form. So there's the first one at y equals x negative 5. And then we've got the point here, y equals x plus 5, negative x plus 5. And I already see a problem with this example here. I'm curious to see if you see the problem as well. So I'm going to leave that open, and we'll discuss it when I get back to class.